Hi, and welcome to the Math Together show where thoughtful educators gather and learn together. I am Sue Loony.
I'm Molly Vokey.
And I'm Heidi Subnani. Thank you so much for joining us this evening.
Yes, we are super excited for our guest today, Dr. James Tanton, who is going to be talking about this very large question. What is your greatest wish for the world?
No pressure at all.
No, none at all.
So fun. So we can be thinking and adding things in the comments. Before we get started, you might have noticed our super fancy beginning. And so we are delighted to say that we have a sponsor for our show. And our sponsor is Exemplars, which is a fantastic company. Their website is right there for you. And they have a suite of performance tasks for K-12 mathematics, where students work with reasoning and critical thinking and communicating in mathematics. So we are thrilled to have them on board and supporting our work, and we hope that you will check them out.
Yes.
So we are super excited. We already see one hello there, but if you want to let us know where you are watching from and say hello in that space, we do try to watch comments. So if you have questions or if you have your answer to the greatest wish for the world right now, we would love to see those things in the comments. So please say hello, and we see a familiar name we haven't seen in a while.
Back. Yay, Garrett.
Yeah. Awesome.
And Nick Johnson, please tell us where you're from.
Excellent, excellent. And so we are the Loony Math team. We have some free resources to support you, and you can learn a little bit more about what we do. We're currently looking to bring on new partners, and we come in and we help schools and districts and teachers improve math instruction in joyful and powerful ways. If you want resources delivered to your inbox, you can easily sign up for our email. It's text. You can pick up your phone right now, and you can text 22828. You can text Loony, and that keeps you connected. But we know that's not really why you're here, so we're going to get going with our guest.
Yes, I have the pleasure of introducing Dr. James Tanton. All right, Nick Johnson is from Milwaukee. That's very exciting. All right, Dr. James Tanton earned his PhD in mathematics from Princeton University. He is an author, a consultant, and an ambassador for the Mathematical Association of America in Washington, D.C., chair of the Advisor Council for the National Museum of Mathematics, and a founder of the Global Math Project, an initiative to transform the entire world's perception of what mathematics can and should be. This program has now reached over 6 million students and teachers across the planet. James has taught mathematics both at university and high school institutions. He advises on curriculum, consults with teachers, and gives demonstration classes, lectures, and professional development sessions across the globe. James is also the recipient of a Joint Policy Board for Mathematics Communication Award for 2020.
Golly gee, hello.
Hello, welcome.
Welcome.
What a pleasure to be here. In fact, I'm honored to be here. What a spectacular program this is. So thank you. This is just a joy beyond belief for me. So thanks very much.
Oh, yes. Your energy's so low tonight.
Oh, yes. I'm sorry.
As usual.
I promise to perk up eventually.
Yes, if you don't mind.
Was that number 6 million with the Global Math Project? Did I hear that correctly?
You so did. It's actually 6.5 million right now, and they're the people we're able to count. They're the ones we're able to count. We keep hearing about the story of exploding dots just in different communities all around the planet, which is amazing. So not everyone has access to technology. So we've got a lot of stories from people from Tanzania and parts of Serbia and so forth saying they're doing it there as well, which is amazing. Amazing. And this is mathematics has just become a global phenomenon. I mean, what a joy, what a delight, what an amazing thing.
Yeah.
Absolutely.
Yes.
Absolutely. Nice. So I think we'll get back into this thing called exploding dots, which maybe not everybody knows, right?
Yeah.
We should definitely talk about this mysterious thing. Yes.
Yes, we're gonna add a couple more numbers to that with our friends watching tonight.
Excellent. 6.5 million and 20. Excellent.
Yay.
Or 200 or 2,000 it should be. Excellent.
Right.
So we like to start off with this question: what is your why? It helps those listening who may not know you yet know a little bit more about you. So What's your why? Why do you do what you
Okay,
do?
so I thought I was asking the big questions here. Okay, that's a big question. All right. So
No.
how long do we have here?
As long as you
Let's
need.
see. So let's see. So Molly did say something in her introduction to me about I'm a man on a mission to transform the entire world's perception of what mathematics can and should be, which just seems like a mild little thing to put in one's
Well,
resume.
really going too small here.
Mhm.
Well, so here's the thing. I do like to think big and bold because so that actually is the key to my why, because I actually had a miserable experience with mathematics in my childhood experience, my schooling back in Australia some 40, 50 years ago. I grew up in a very Anglophilic system where kids were just meant to just sit at desks in rows, face forward, be quiet, memorize, and do. It really wasn't about asking questions, exploring why questions, let alone what if questions, certainly not what if questions. What else questions, what if questions. So it really was just memorize and do. And I was good at it. I was even labeled gifted in mathematics, which I thought was silly because I was just repeating what I was told to do and do it 50 times over. I found it joyless. I actually found it joyless. And there were a couple of times I did actually ask my teachers why questions, and I was completely knocked back. I remember being very confused in year 5, grade 5, about the long division process. We're just told you write the big number under the funny symbol, you write the smaller number to the left, and you do blah, 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 just do it. But I want to know why. I did not understand it. Never got asked that question. And I became very aware as a kid then, my job was just to please the teacher, not to understand for myself. I was very cognizant. I was doing these workshops to make my teacher happy, not me. It wasn't about me. It was about my teacher. I was a 10-year-old, how old I was then. It was crazy. And I remember in year 9, as an age, 13, 14, being taught the Pythagorean theorem. Now, when I say being taught, being told the Pythagorean theorem. So I was at a big public school in Australia. So there's like 37 of us kids in this big classroom. The lesson was, get out your rulers, protractors, and pencils, draw 3 examples of right triangles, measure the 3 sides. You must call them A, B, and C. It has to be those letters. Always has to be those letters. Of course it does for right triangles. Yeah. Then work out A squared, then work out B squared, then work out C squared, add 2 of them, and see you get the same as the third one. Okay, I had 2 problems with that. I had 2 problems. I didn't believe anyone was actually ever seeing A squared plus B squared equaling C squared, because no one can measure precisely. You can't. You'll get close. Right. It might be believable, but I knew no one's actually seeing it being true. Right. But yeah, I let that one slide. But I do remember raising my hand and asking Mr. Phillips, and it's terrible, you remember your teachers' names. When you're a high school teacher, you realize, oh, what's the impression I'm making in my kids? They're going to remember me in their 50 years' time, like I'm doing to poor Mr. Phillips now. Right. But I asked him, Mr. Phillips, how do you know this wasn't just a coincidence, 111 times in a row? 37 kids doing 3 times. Could just be coincidence we all got the same answers. And his answer to me was, go back and draw another 3 triangles.
Of course it was.
He's just telling me, yeah, I'm not going to tell you. The point is not to know why. Just do it. Just believe it. And that actually kind of made me angry. And that could have shut me down. There was something in me as a kid that said, okay, my job is to figure this out on my own. Now, I couldn't. Though I remember like years later coming across something I read somewhere that explained it, and like finally I got it. So, but my point is, math was joyless to me. So my experience in mathematics from K through 12 was one of no joy. And it wasn't until university that I actually just happened to stumble upon an abstract algebra class, because I kind of went to the sort of science and physics side of things, and I took some math classes then. And abstract algebra is about why arithmetic works the way it does. Basically, it's about the why questions. It was answering all the why questions I was yearning for as a kid. And I realized, oh, I am a mathematician. This is what math is actually about. It's not about getting answers to computations and usually with speed. It's about asking the why and the playing and the what else's and the what ifs. It's that exploration. What I was pining for, didn't know it could be, and there it was. And that's when I changed my degree. I didn't become a physics major. I went to become a pure maths major. And I went all the way through. I went and got my PhD at Princeton, as you heard, and the highest level you can go in mathematics. And I was in that university for a while. But I always had that call for teaching, which really is driven by that same burn. Let's not have another human on this planet go through the misery I went through on this most beautiful subject of mathematics. And so this is a very long answer to the why question. I could spend the whole episode just talking.
That's okay.
I'll keep going. But the story goes as follows. But I was young and I was having a career and I was getting married and all the rest. So I followed the standard track, get your PhD. Of course, you go into university teaching, you go to assistant professor, associate professor, blah, blah, blah. But then I sort of fell into doing some PD for teachers. I don't know how that happened. This is the late 90s. I wasn't qualified to talk about high school teaching or K-8 teaching. And I realized I didn't know what I was talking about. But it made me start looking at the curriculum in the US in the late 90s. And I was shocked because I saw the same dry, just memorize and do experience I went through some 30 years ago in another country. It was still the same joyless curriculum. And I said, okay, this can't be. So rather than be a professor that complains about high school teachers, like all professors do, I learned that all high school teachers can then complain about middle school teachers, and probably middle school teachers, everyone complains about everyone else. No. Let's be honest. There's a reason why the system is the way it is. Let me actually understand it. So I decided to become a high school teacher. And I actually chose high school. I actually thought about, do I want to become K through 6 or want to become middle school or high school? I kind of chose high school, and forgive me for being so frank here, but I felt like it was the most joyless arena of the curriculum for the reason that standardized testing and assessment becomes paramount in grades 9 to 12. The feeling there is our job is to get you into college, therefore pass those exams. So it's like it has that sort of lockdown mode, like we all know what lockdown feels like now after COVID for a year. But it had that sort of mentality for the high school world. So, okay, I was very interested in the question, what's the wiggle room in that very strict mindset that I've got to get my kids through exams? How can I still speak to the human joy of the mathematics story, even in that environment? So I became a high school teacher, and I loved it. But I will say it was the hardest job I've ever had in my life. It is school teaching is unbelievably hard. I mean, it's just mentally wearying. It's just so frenetic. You're pulled in all different directions. There's no time to reflect on the practice of teaching at all. I mean, university world is pretty darn cushy compared to high school world. And of all the arenas of education that require the most reflection and thoughtfulness about them, you're given no mental space and no time. It was just loopy in my opinion. Nonetheless, I valued it
during a pandemic.
And they tried doing it during the pandemic. Right? Absolutely. So I was fascinated with the question. So my why was actually, I guess, anger. I've never been exploring the why questions when I was a kid. Let's turn that around. I don't expect every child on this planet to love mathematics, but I'd love them to know that there is something to love about it if ever they so choose, that there's something to it. It's actually fascinated humankind for 10,000 years, if not longer. There's got to be something more to it than just getting speed answer to multiplication problems. There's more to it than that. There's got to be something more. Let's share that with the world. So to answer your question, yes, I'm driven by the passion to bring joy to mathematics. That's it.
Just to the whole world.
Yeah, well, why not? I mean, okay, as we know, we apparently like big, bold, brash questions together. You just asked me one and I asked one back. So
that's right.
There we are. If you're going to do it, do it, I say.
That's
right. Absolutely.
That's right.
It is surprising to me sometimes. We seem to have this thread over and over in with people that we've been talking to about how we're working through school and we have this really unfortunate experience with mathematics, and it's always so surprising to me that you stuck with it. Like, I mean, even though you went the physics route initially, you eventually found the math that was joyful for you. And thinking about all the people who never had that opportunity, that always is in the back of my mind of who have we lost along the way where they could be and in enjoying and finding meaning and expression through mathematics, but because of how we've done it for so long, we lose them along the way.
Right.
But
they've never had the choice.
People.
Yeah, I want folks to have the choice. They don't have to choose mathematics, but I want them to be able to choose whether they want to do mathematics or not. And it's just a loss. And we don't get me wrong, we have an educational system that's worked very well for the last 200 years for the people that it works very well for. So now, what about the other 98% of the population?
Right. And that in mathematics is not the same as it is in other subjects, right? I mean, when you ask adults, or if I just tell adults what my job is, if I'm introduced to somebody new, that, you do math, they either think I'm like super smart or such an idiot. I mean, there's not a lot of in between there. So it's just, it's unfortunate that we've lost so many people along the way.
Well, I mean, of course, what is the world's perception of mathematics, what they experience in school. And that's why I really want to focus on school mathematics. That's the most math people experience. And often that experience is about computation, about getting answers to what questions, usually with speed, usually under pressure, which is actually not fun, actually. I mean, some people thrive on that, but it's not everyone, certainly not everyone all the time. And that deeply worries me. And especially in the 21st century, if I really want to know the answer to 37 times 53, the first thing I'm going to do is this. And I'm a professional mathematician. Exactly. Don't deny kids their place in the 21st century. Now, the more interesting question is, well, okay, you got that answer, but what if I did then 53 times 37? What if I switch it around? You get the same answer? What you do? There's a little mystery there. Is it obvious that, A times B should be the same as B times A? And then actually, if you think about this. If I did the standard school algorithm of 37 times 53, you do like the 3 times 7, 3 times 5, write all that middle stuff, and then you add up the stuff in the end, and then switch it around, do 53 times 37, or I hope I said the right way around, you get actually completely different looking middle stuff. You get the middle stuff looks different, and it's actually, it should be a shock that all the stuff in the end adds up to the same number. That's a moment of beautiful shock. Let kids be shocked by that, and there's a deep question. Why should those two algorithms give the same thing in the end? Because they look very different in the process. What a great opportunity to just be a moment of wonder in the world, even over some standard school arithmetic.
See, that's so interesting because the kids are taught the commutative properties so early that teachers don't explore. By the time you get to doing double-digit multiplication, you're not really exploring what's in the middle, like the meat of that,
Yeah, exactly.
That's interesting to think about.
Well, even think about our definition of multiplication. So people always argue, what is multiplication? But I'll say this, I'll give a definitive answer. In the world of counting numbers, multiplication truly manifests itself as repeated addition. That's the correct answer in the world of counting numbers. But there, the definition is asymmetrical. Think about it. 4 times 5, we think of that as 4 groups of 5. Philosophically, that's very different from the other way around, 5 groups of 4.
That's right.
Now, a picture of 4 groups of 5 is a blob of 5, blob of 5, blob of 5, blob of 5. And a picture of 5 groups of 4 is blob of 4, 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 and a blob of 4. That's actually a very different picture. It's surprising it's the same number of dots in the end, 20 in both cases, actually. There's something deep to think about there. And there's not actually have that flash of insight. Oh, if I arrange my blobs in rows like a rectangle, if I look this way and see 4 groups of 5, but change my perspective and look up down from the rectangle from above, I'll see 5 groups of 4. Same rectangle, must be the same number of dots. Oh, must be the same answer either way. But that's a beautiful moment of discovery, and we just deprive kids of that because we say early on, multiplication is commutative. We now know that, and then suddenly we've just ripped any chance of surprise and joy and intrigue and mystery and delight and epiphanies that come from that. It makes me sad.
It is. But at the same time, what you're demonstrating, James, is it's small little tweaks to open it up, right? So if we can just spark that joy and enthusiasm in the educators, it doesn't have to be a tremendous amount of work to open it up. Just asking why. Why do you think? What do you notice? Just opening up for curiosity.
Absolutely.
Yeah.
And that's what I meant. I said earlier, I was very interested in the question, what is the wiggle room in this conversation? I just mean these little baby steps, those little tweaks. All you do is nothing big. There's nothing big and transformational here. So maybe just change your mindset to find those little cracks that actually give that chance of just ask a question. Asking question is such a great gift for the world because we actually teach kids not to ask questions in maths, actually. We kind of squelch that. No, ask questions.
Yeah. That's really useful advice and something that we can take forward from this conversation. So what we do, just for people watching behind the scenes, as a guest is agreeing to come on and chat with us, we said, well, what's your question? Like, what do you want to talk about? And so, James, we got this one and we were like, oh, wow. Okay. So we have been so excited to talk to you and see sort of where you see this headed. And I guess, as we get going with your answer, what is your greatest wish for the world? If you're tuning in, either live or later, go ahead and plop your answer to that into the comments because we can explore those as well.
I would love to see.
Excellent.
Yeah. So where do we start with this, James?
Do you want to give an answer to those each, or do you want me to just dive right in? Because I've done a lot of talking so far. What would you like best? What would you like best?
I think we can give the answers. Go ahead, Sue.
All right. So I had thought earlier, I wonder if we'll have similar things. I mean, I had to stay away from the obvious, which is that COVID-19 would go away. I wanted to just let's be bigger and existential. So I wish for a world full of kindness. I wish that everybody would approach one another with kindness. That is my greatest wish.
Beautiful. I'd say no to that.
Yeah, I think mine is related to that. I would like to give everyone the ability to step into somebody else's shoes.
Mm, mm.
Wow.
Empathy, understanding, connection to others. Beautiful.
I think if I've learned nothing else from this past year, it is that people do not know how to do that.
Beautiful. Wow. Oh my God.
Mine is not as deep as either of those. So
you just want candy?
Yeah.
That's good.
Candy?
I was thinking about, like, I want a redo. I want a redo of how we do school. I want a redo of how our society functions and doesn't function for some people. So
you think
for
that's
so
like
many people.
Small? Yikes.
Well, but it's like it's specific to like, but redo. Like we have this opportunity in some sense to have done things different this year. And it feels like sometimes we have replicated what was and not thought about what could be. And so I want to redo.
I
love it. Okay. All right. Well, okay. You guys have beaten me. You're awesome. Okay. That's brilliant.
We have Ellen. Ellen is chiming in, James, if you don't mind.
Oh, yeah.
She's saying she wants kids to love learning, which goes along with your wish, right? Includes both social, emotional learning and academics.
Interesting. Yeah. And I saw Ellen has another question there, which I'd like to get to later on. Sort of a bit off the different theme. We'll get there. But so let me just reveal how my brain works here. I mean, of course, I am so 125 billion% with each of your answers. Of course, I mean, what is my greatest wish for the world? If I really was to answer that in a genuine hearted way, like the opportunity for everyone on this planet to live a life that's full of safety and kindness and health and ease and comfort and freedom from violence and freedom from disease and the ability to live who they are and be who they are and just thrive and feel safe to thrive. I mean, yes, absolutely, yes. And then I say, okay, well, that's great. It's but kind of abstract. And my brain says, well, okay, shall I really try to focus on something more? Like, I mean, obviously, I don't want anyone to live in hunger. I don't want anyone to live in poverty or disease. I don't want anyone to be living in a world where they don't feel safe. And I could try to solve those problems. And then my brain says, but I'm just a single human being. And when I think of like world hunger, that's just so overwhelming that my emotions take over me that I just kind of actually shut down because that's too big a problem. And that was, to me, like my entry point to how to answer a question like this. What is my greatest wish for the world? Well, would be that, okay, I cannot solve one of these big problems. I can't. I'm afraid I can't solve poverty. I'd love to. I wish that for the world, but I can't do that. I wish everyone had lives where they felt safe. I wish I could do that for everyone in the world. But it has to come from the collective experience. So what I really wish is for the world, so for everyone, each and every person on this planet, to be able to, I guess, first of all, observe challenges and problems around them, just be observant to the world. That's the empathy theme that you were speaking about, Molly. And want to have the kindness to do something about it, and it could be like a redo or just a reset of things. But really in the end, even though you might have a strong emotional reaction that feels like you shut down, to acknowledge that, to say, yes, I am human. I am going to have a human reaction, but nonetheless, take a deep breath and try to do something, anything. I don't care what it is, a small, tiny step. Everyone felt they have a sense of agency in the world. Take a problem for your community, be it the globe, which is too big, maybe, your nation, probably too big. What about your town or your village or your school or your family or your immediate family? Maybe you've got one parent and two sisters. That's your community. And notice something that could make your life, that could uplift the life of your community. And feel like you're willing and confident enough to do something. And I mean anything. And I mean any baby step. So my greatest wish for the world is that everyone in this world would be their honest human selves, acknowledge they're going to be, full of faults, going to have like quirky feelings, going to feel like they want to shut down. Nonetheless, take a deep breath and be willing to do something. That's it. And that way, if we're all able to do that, then maybe we can start solving problems like world hunger and a lack of feeling of safety and a lack of feeling of empathy and so forth across the globe. And the reason why I think this relates to math, because do you know what? I actually think math is a perfect vehicle for teaching the confidence and the willingness to do something, anything. Okay, which I've probably explained, because how on earth does that connect to math? I bet people are wondering. I can talk about that if you like.
Yes, please.
We had Frances Sue on last week, and it sounds very Frances Sue-ish.
Absolutely, absolutely. Yeah. All right. Well, so I did think of this. So one thing about mathematics, people say maths is always full of problems. Okay, that sounds a little bit trite, but there's something to that. But the thing is, the problems often look scary. So I just wrote down something very quickly, just as I was in the backstage. Imagine I took this middle school problem. Here's a middle school problem on, is the screen the right way for you guys?
Yes,
Yep.
good.
It is.
Yeah, it's take two mixed numbers and divide them. Okay, so there's a math problem. Now, here's the honest thing. I am a human being. There are two fundamental steps to solving any problem, which no one ever talks about. Here's my first fundamental step in problem solving. Be your honest human self and have an emotional reaction and acknowledge it. And I'll tell you, when I see that, I go, panic. Ugh.
Yeah.
Who wants to do that? Who in their right mind wants to do that? No one.
Right.
That's the honest reaction. No one wants to do that. That feels
It's about
contrived,
one.
false.
Done.
Yeah, exactly. That's okay. That's okay. I say actually acknowledge. I think if we had kids just write down a word that's their honest human reaction to what is, and it doesn't always have to be negative. It could be like intrigue, could be delight, it could be flummox. I don't know what to do. I wonder how this is going to work out. I mean, whatever the emotion is, yes, bring it on. I love mixed numbers. Yay, it could be whatever your emotion is. But it's going to be varied. It's going to be lovely. But then step 2, which no one ever talks about, is literally take a deep breath and do something, anything. It looks like a baby version of what I just said for my greatest wish for the world. I've given you a problem. Okay, it's a little contrived, but I'm going to practice doing something, anything. And I mean literally anything. Maybe your anything could be, I don't know what to do, I'll just turn the page upside down. Does it look different? Yeah. Well, at least I did something. It could be draw a picture of a tree or something like that. And, I'm going to give you my honest anything right now. I think we said this already. If I really needed to know this, I'm a citizen of the 21st century. Let kids be citizens of the 21st century too. I'm going to do it on my calculator. So I'm going to, what do I write down? We're at 7 2/3. All right. I don't know what 7 2/3 is. Let's try that. Let me see it on the screen. This is going to be bad.
Yeah.
I do this.
Oh, I like,
All right,
I like this.
7.666. That's close enough. Divided by, what did I say? 5 3/4.
5 3/4.
Divided by, press no. Divided by 5.75. Ooh. I can't see. You can't see it.
Oh,
1.333.
1 1/3, sort of, right?
About 1 1/3. Okay, my emotions just changed. It's intrigue. Could that be 4/3 in disguise? Now, suddenly it's become a mystery. Now I've got a mystery. Do you think that is 4/3 in disguise?
Did you just randomly pick these numbers?
I did, actually.
Okay. Just checking.
Okay. Well, so now your emotion is like disbelief.
No, I'm intrigued. Now I want to know.
Right. So I've just changed the emotions on this. We're being our human selves, and now we're suddenly intrigued. Great. I love it.
Yeah.
So now we have to do something. What can we possibly do? I mean, I've got my calculator. I can put in more decimals.
No.
Oh, don't do that. It's not fun. I want to have fun now.
Don't do that.
Yeah, suddenly math has become fun.
Do this
algorithm. So since I'm the guest, I'm going to show you what my brain does.
We're old.
My something is, I actually like this notation better. I like writing fractions this way.
Okay.
It's just me. What can I say? But what I see there is I don't like the thirds in the top in the numerator. So my brain says, I've got a problem. I don't like thirds. So I say, what can I do? How can I get rid of thirds? So I don't like them. I want to get rid of them.
You're going to multiply?
Yeah.
Are you, okay.
I do what Millie said. Multiply. What if I multiply the top by 3 and the bottom by 3? Would that keep the fraction the same?
Yeah.
Okay, the top line will be 7 times 3. That's 21. Plus 2/3 times 3. That's 2, isn't it?
Yeah.
Okay, so the top line is 21 plus 2. Sorry, now it's getting scrawly. What's the bottom line going to be?
Good idea.
Yeah, it's 23.
What's the bottom line? I love 23.
Well, 23 is better than
it's
7
It's better.
Yeah, I'm with you, but it's better than 7 2/3. Yeah. You're right. I'm still having an emotional reaction. I don't like 23. I'm with you. I'm having I'm honest. You're being honest. I love it. Be honest. And the bottom was 15 and 9/4. Am I right?
Yes.
All right. 15 and 9/4.
Not as nice, but that's okay.
Not as nice, but that's okay. So we've got a little bit of resignedness there. All right, but I don't like the fourths on the bottom. What can I do about that?
Multiply by 4.
Yeah, I'm going to do that. Let me get a pen. Who knew I was going to do a math lesson? Times 4.
We kind of expected it.
Yeah, I know. All right, so what's the top line going to become?
23 times 4.
Another problem. Oh, there's full of problems.
Yeah.
Am I right? 100.
I think so.
What was that, Molly?
88.
92.
92?
What? I did it wrong?
23 times 4 is 92.
Oh, sorry. I did.
Yep.
It'd be like 20 times 4 and 3
I
times
did
4, my brain says.
22.
Is it 92?
Mhm.
Okay, 92.
I believe it's 92.
Yeah, you're right. I did 22.
Don't do anything half of the bottom line. I don't like hard work. So I see 60 plus 9. Is that right for the bottom line?
Correct.
Yes. Yep.
So 69. All right. Okay. Oh, by the way, I guess we just divided mixed numbers by following my nose. We just used common sense. Didn't like thirds, got rid of them. Didn't like quarters, got rid of them. No one likes hard
Natural
work.
numbers.
Yeah. By the way, are 92 and 69, are they friendly to each other?
No.
Not so much.
Not so much.
Oh,
Hold
They're
on.
not both divisible by 3. They're not,
no.
So it's not 4/3.
It must be close, though.
Well, anyone got a calculator? What is it? It's a calculator. Someone had a smartphone earlier on. What is it? What's 92 divided by 69?
hold on.
It's 1.1 1⅓.
It is. But it,
Yeah, but there was
now flummoxed. Okay, my next emotion is flummoxedness. If that's an emotion. Wow, is that really 4/3?
But there were several numbers. It was a repeat. It was a decimal with lots of places, and
Yeah.
so when we
Right.
round that, we don't get nice numbers that might have common factors necessarily.
But I believe our calculations so far, so I really believe it is 92 69ths in the disguise. And according to Molly's calculator, that really is 1 followed by an awful lot of 3s.
Right. So we don't know if it's repeating.
Technically, we don't know.
It looks like it's repeating.
Wow. Okay. All right. So if I divide the top number by 4 and the bottom number by 3, because that's really is 4/3 of disguise, there should be a common factor then. Is the top number divisible by 4? Is the bottom number divisible by 3?
Yes.
Yes.
Okay,
Yeah.
what's
Yes.
the top number really?
23.
4 times 23.
Yep.
And what's the bottom number really?
21. No,
Right.
sorry. Wait a minute. Yes, 23.
23. Right?
3 times 23? Oh, heavens
Hey,
to Betsy.
come on now. We just don't know our 23rd tables.
We should memorize those. That's right. You're right.
Darn
Because
it.
back to Ellen's question, if we only memorize our multiplication facts like all the parents insist, you would have been fine on that
Right.
one.
That gets to Ellen's question, actually.
Exactly. But my point is, I mean, this might be the best examples I made up just as I was in the backstage waiting to come on. But the point is, I could take a math question like this is just a tedious, horrible workbook question and make it a human enterprise about teaching problem solving. I don't like answering, having an emotional reaction. I just played with it and got an answer. Now I'm intrigued by 4/3. Then I just multiply by 3 because I don't like thirds. Because if there's something in life you don't like, just get rid of it, make it go away. But there are consequences. I have to multiply the top by 3, I have to multiply the bottom by 3.
But that's just it, James, right? Because I think what happens to kids and people alike is they see a fraction and they become paralyzed.
Yes.
So that's your greatest wish, is that people just do something and it doesn't matter if they're going
because
to
it's so easy. Because when we face an impasse, we often just shut down because of our emotions. So my greatest wish for the world is, yes, be on yourself, recognize you shut down, take a deep breath and get past the impasse and do something nonetheless.
Oh my gosh.
And I think math is full of moments like, this is probably the wrong example, but full of constant moments like this. You just practice the idea, I don't want to do that. I want to shut down, but I can do something nonetheless. I just steel myself, I can move forward. Let's teach that confidence. Let's teach that sense of agency. If you do 12 years of this, you're a pretty confident Asian person, Now apply that to things you like in the world around you. Like, how can I help my village get clean drinking water? How can I, help the homeless people I see in my neighborhood? I mean, whatever you notice is a problem, you can always do something. Doesn't have to be the best thing.
I love it.
I do too.
Get started. Yeah, just acknowledge your emotional reaction to the situation and get started. I love it.
Yeah. That's such a life skill. Obviously what you're saying is that you want people eventually to be able to solve real life problems. And
Yes.
mathematics is a vehicle for teaching stamina and perseverance and
I
self-starters.
truly believe
and
that.
all of that.
If we teach it that way, if we don't teach it as a set of confetti pieces, one little random thing to memorize and regurgitate. For example, yes, feel free to memorize the multiplication table if you'd like. And many parents have this gut feeling that math is vital to success. So good for parents really want to hold on to this. Don't mess with my child's chance of success in maths. But their only experience, by and large, has been one of memorize and do. So they have no other perception of what maths can be. You don't actually need to know your 23rd times tables there.
Clearly we do, James.
Well, but I was pushing it, and of course we're under pressure because we're live right now. We're trying to do something, move things forward. But you would map your way through it. You're like, I want this to be 4/3, and you'll probably battle your way out of that until you finally realize, oh, multiples of 23, which is not natural. But I bet you would have gone there eventually.
Yeah.
Right. But that.
So what we need to teach kids is not. Oh yeah, sorry.
No, I don't mean to interrupt you, but you're very close to answering Ellen's question, right?
Yeah, let's go there.
Yeah.
Ellen is asking, and yes, James, and you'll probably be able to make your point. How do you respond to parents who just want educators to teach the traditional ways of how to get the answer?
And I'll tell you what I do, because most often, so a number of years ago, James, you made a video on the area model for multiplication. And every so often on Facebook, that horrible video goes around about the teacher who's actually trying to teach it that way, and then the people making coffee, and like my parent, my parent friends are all like, why can't we just? And so I cut and paste your video into everyone's feeds who's saying that, because it is that idea. I think you make an excellent case for this idea of why we do want students to learn math in ways that are not traditional and not the ways that we learn them. But I'll let you continue with that.
No, absolutely. I mean, one point that doesn't work too well is because it's too abstract. I mean, we must teach our kids the long subtraction algorithm. And yet when you say you hand a $10 bill to a shop clerk, I'm giving the item costs $8.73. We don't expect the shop clerk to get out a piece of paper on pencil paper, go 1000 minus 873 and do all the carrying and borrowing. No, we expect them to say, 7 more cents gets you to $8.80, 20 more cents gets you to $9, $1 more, which is not the traditional algorithm. Yeah, it's not what we expect people to do in the real world. But that's too abstract a notion. That's hard. Because that visceral feeling parents has that math is somehow vital for success. Don't dare change anything for my kid by doing something that I don't recognize as math. So multiplication table becomes the big thing. Your kids must memorize the multiplication facts. I have a hard time with that. I really have a hard time with that. I'd much rather teach kids. Well, in fact, this is what I advise parents, and this is what they actually believe me. Write out the 10 by 10 multiplication table, not the numbers in between, just space all the numbers, and have a conversation that goes like this. Which ones are in your head already, which are easy to do? And you'll realize all the ones times tables are easy. And then most of the 2 times tables are easy, and some other ones are easy. For some reason, the kid might have 6 times 6 in her head. Great, 36 in there. And then you'll realize things like, well, do you really have to memorize 100 of these things? And then you realize, once you figure out that 4 times 5 is the same as 5 times 4, actually, it's only a good chunk of that table is the same as the other half. So you don't really need to know those. And then you'll circle the ones that still aren't in your head, 4 times 6 might be gone, or 7 times 8 is the classic one that's always gone.
Yes, classic.
But here's the thing, then make it a meta conversation. You're not going to memorize 7 times 8 is 56. Just say, well, what did you do? You had 7 times 7 in your head. You seem to know that 49 is the perfect square. What could you do to go from 49 to 7 times 8? And make it a meta conversation. Even that meta conversation is probably enough to have 56 stick in your head. That works really well. But that's actually saying to parents, the point is, don't rely on memorization. Memorization is going to fail you. What you need to figure out is how can you do something when memorization fails? End of story. And yes, I've got 49 in my head, 7 sevens. I bet I can get 8 sevens by adding 1 more 7 to that. 56. Great. That's great. And for fun, do your 13 times table just by using common sense. Not because memorizing it, but you can figure your way through it if you just practice using common sense, following your nose. That helps a lot because I've taken what parents expect their kids to be doing and shown how it's really about a meta conversation of finding that inner confidence to move forward nonetheless. It's that number sense, that number play.
It's looking for the pattern, which is what mathematicians do. So it's looking for the pattern and the structure within the multiplication table, which is which is the skill that you'll transfer out of learning your multiplication. Like
Yes.
if you are only focused on learning individual facts, you're never looking for the pattern. You're just rushing right through that.
Now, don't get me wrong, I'm going to sort of counter my own argument. At some point in your life, you might keep stumbling over 4 times 6. You might just say to yourself, you know what, let me just get the number 24 in my head, so stop stumbling. There's a purpose. I'm making that choice for myself. There's nothing actually wrong with memorization when it comes from your own personal sake. Let me just get this thing down because I'm tired of stumbling over it. That's fine. If that happens to you in grade 5 or grade 6 or grade 10, or like me when I'm 54, maybe, that's when I'll do it. But,
Great.
Whatever.
Oh my goodness.
Excellent.
Oh.
Well, let's think about how, we could keep this going all night and, having fun. But this has been so joyful. This is just really illustrated that sitting around talking about division of mixed numbers, we were laughing.
Not
and
everybody's
pondering.
favorite. Not everybody's
No.
favorite.
So sorry to spring that on you, but there it was.
It was fun. So
Yeah.
I guess we can move into how we can learn some more things from you and stay involved and let other people know how they can, get more of the wonderful things that you put out there.
Okay, so let's see. So so you have my Twitter handle, so that might be the easiest way for people to contact me. Just if you've got an actual question, I mean, you can easily find my email if you really hunt me down. I'm very public. You'll find me. But let's see. So I've got a lot of stuff out there. I guess the big thing is what we mentioned earlier on. This intriguing thing called exploding dots. That's really sort of got the whole 6.5 million phenomenon happening. That came from me teaching year 11 students how to divide polynomials, to which I said to myself, as coming from the research math world, why? Why do we need to divide polynomials? As a research mathematician, did I ever divide polynomials? Where are the parents breathing down my neck? You must teach my kid how to divide polynomials. No, none of that. So the thing is, I realized that's the story of place value. The whole story of place value, what you learn in early grades and middle school about base 10, how you do with being base 10. High school algebra and polynomials is just a repeat of all that about base X. It's the story of one of humankind's greatest intellectual achievements, the invention of place value. And I realized my students are very good at doing place value. They know what 273 means, but they hadn't actually internalized the story, my high school students. So I came up with this way of doing this very visual, natural approach. Let me tell you the human story of place value, called exploding dots. And we'll just start at the beginning, from the very beginning, and work our way through from kindergarten, how we write and think about numbers, to all the grade school arithmetic you think you know so well, to high school algebra, that polynomial algebra that I was required to teach you as a high school teacher. And let me also take you to unsolved research problems, still based on the same material. It's one storyline that spans K through 8 through 12 through graduate research. Whoa, that's it. And that shows that mathematics is a continuous storyline. We teachers can so often get locked in our little horizontal slice. I teach grade 4 maths, or I teach, high school algebra 2. We forget that's not the kids' experience. They are literally going kindergarten to middle school to high school and beyond. That's their journey. Our journey is 90 degrees to that. So we've got to think of their journey, not ours.
Wow. And
exploding dots is one of these rare stories, which is place value, which permeates every standard there is out there. And yet we can make kids do place value, but we haven't really helped them internalize, really know it and see it in their own deeply cognitive way. So that's what the Global Math Project is all about, spreading that one particular story to the world. That seems to have really taken off. So yes, if you want to learn more about me, just go to globalmathproject.org. You'll see on the main page an easy way to see exploding dots in particular. You'll see other things there as well, but exploding dots is the thing that's taken the world by storm. So why not do the thing that's brought joy to the world? Go with exploding dots. It's good. I like it.
Yeah,
quite a partial to it.
Well, and as are 6.5 million other people, and I think that's the way that it is quite literally global, and it's a way for students to communicate with other students around mathematics and have that common language and that common story, which is really important.
And I'll tell you, it's amazing because I still get emails and tweets and so forth from students. They're discovering new ways to think about stuff that I haven't thought about to do with exploding dots, or how to see the math they thought they knew so well from school books in the light of the sort of the visual approach we have there. It's just beautiful. It just keeps on growing, and people can keep playing with it and keep discovering new things, new to the world. It's incredible. That's math. Math is alive, organic, and deeply human. Voila.
Awesome. And so you've given us a place to go and to all be connected around this common story in a really joyful way. So definitely we encourage you to check that out. it's still, and it's an event that kind of we encourage to happen at the same time in the fall still. Is it still kind of centered around a fall activity?
So yes, to get this off the ground, we decided to do something flashy and declare October 10th to be Global Math Week. We just sat there and just declared it. There it is, Global Math Week. So back in 2017, we'd said, teachers, just try this out. Just have one experience sometime during the week and share it on social media. And do you know what? That first week, 1.7 million students and kids did. So it became the thing.
Wow.
But now, of course, we've got ourselves locked into a silly position here because now people think Global Math Week is the only time you do exploding dots. It's really like all year long. So yes, of course we love Global Math Week, but the message is do it all year long. Do it all year long.
There we go. Excellent. Excellent. Thank you so much. Well, it has been a pleasure having you here. We really appreciate everything that you do. And I love your message, which is, be willing to do something. When you face a problem, be willing to do something. And math is a vehicle where we can practice and gain that confidence to believe that we can change the world. And boy, we need that. We need that right now.
Now more than ever.
Yeah. Thank you so much. All right. Well, it's been a pleasure. And we're so glad that you were here and able to be with us. And we encourage everybody to find out about the Global Math Project and Exploding Dots and just bring all that enthusiasm forward.
Yes.
Beautiful. Here's the math joy for the world. Love it.
Yes.
Thank you.
Awesome. All right. Thank you so much. Take care. All right. Awesome. So we are thrilled to have had James here, and we do encourage you. We were involved early on as ambassadors, and have been able to do those lessons with students and with teachers, and so we encourage you to check that out. As we wrap it up, just a reminder that we are brought to you by exemplars, and so again, those are wonderful, exciting problem-solving tasks for you to get students involved in some powerful mathematics.
And we are, again, if you're interested on getting on our mailing list, you can do that by texting Loony to 22828 or finding us at loonymath.com. We're looking for partners for this upcoming school year, and we are happy to help you and your students learn some more joyful math together.
Awesome. And next week, we are really, really excited. We have a guest coming in, Tom Hayek, and he will be talking about the future of education, what it looks like in a post-pandemic world, and how we get there and how we begin to transition. So he'll be having this conversation with a trauma-informed lens. So we encourage you to check it out either live or on the recording. So thank you so much for spending some time with us tonight. It's been wonderful. Remember to always be curious and always be kind. Take good care.
Good night, everyone.
Bye-bye.